All right, so today we have my friend Chris Wiggins. He is a professor at Columbia University, but also the chief data scientist at the New York Times, and also co-founder of Hack NY. Is it Hack NY or Hack New York?
We like to say that most people call us Hack and Y. People who don't know us so well call us Hack New York. And then if you're really friends, you can call us Hackney.
So Chris has been on the podcast, but today we're going to talk about his new book with his fellow faculty member Matt Jones called "How Data Happened: A History from the Age of Reason to the Age of Algorithms," which I have to say is a great read. I have an advanced copy. I will link to the book in the episode notes, and I will also link to the course page, because this book is based on a popular course they teach at Columbia. So actually, first off, Chris, obviously a book is different than a course, but beyond kind of the form factor, how does the book differ from the course?
Well, the main thing is there's no code in the book. So when we taught the class, we wanted really to bridge the two cultures, and so there's a lot of work that we spent in making sure that we read an important paper on Tuesday and then we actually do Python on Thursday. So we didn't even attempt to include that whole half of the class in the book. The other thing is, one of the benefits of a class is discussion and getting students to really engage with material and to hear each other's opinions. So that sort of that sort of function of a class where I really try to draw out students' take on the readings. That's certainly something you don't get reading a book by yourself. When we do this in class, what I do is I ask students to submit a comment in Slack the weekend before, and then I do a little natural language processing, and I actually computationally analyze what the student said, and then I read back to the students here are the themes in the comments that you made, and then draw out students, because at this point it's a pretty big lecture class, draw out students who had made comments that I thought really typified what everybody said, and use that to structure the lecture. I try not to have the lectures be just the reading of the book anymore. When the first couple of years we taught the class really shaped the material, but at this point, now that the book really is informed by all of that stress testing in the class, now when I teach the class, I try to use the class time to bring out the students' observations, which, as you may have heard me say before, students are always telling you the future if you listen. So we try to use the class time for the students to tell me the future.
So implicit in what you said, right? The Python code, Columbia students, Ivy League. So does this mean is the book a lot more accessible?
Oh yeah. Well, I mean, we designed the class, we designed the book. I guess we designed both. So we designed the class to be accessible with no prerequisites. So there's stuff that we think is new to technologists and new to non-technologists alike in the class material. And certainly the book we meant to be for any curious reader, basically anyone who actually wants to understand how data happened.
So because the book doesn't involve coding, what's lost in the book? Or is there anything lost in the book?
Relative to the class? Well, yeah. I mean, the interaction with their peers. I hope that the students find that the interaction with their peers is useful. And I mean, obviously, there's a way of knowing things when you're actually functionally engaging with data that you are not getting if you're dealing with data rhetorically or dealing with data critically. So in reading a book, what you're really going to emphasize is the critical engagement with the subject material. And by critical, I don't mean this is bad. By critical, I mean really analyzing how these techniques developed and what they mean, and the communities who developed them, what their interests were, how these techniques are used in our modern world. Or contemporary environment, but you're not going to get the kind of engagement that you do when you actually do stuff. So when we engage with code, what we do is we pre-author Jupyter notebooks, well, in Colab, right? So at this point, we're leveraging Google Colab so that the students don't have to install or write any original Python, but they get to execute in data science, arguably the way a lot of data scientists do in industry in Colab. So the functional engagement with the material is lost, and it depends a lot on the mindset of the student. Students who are sort of hackerly will break the code and learn something, and they'll dig in and they'll do stuff we didn't ask them to do, and correlate things with each other and have fun and explore. So that is that sort of play aspect of playing with the data directly is going to be lost.
So for you, Chris, personally, so this course, of course, is co-taught with Matt, who's a historian. So what are the challenges of combining kind of the more quantitative and historical approach to thinking about these things?
So Matt and I come from different traditions, intellectual traditions, and we bring a different set of observations to most of the material, and we draw on complementary literatures. So it's been a lot of fun, really over the last almost decade, taking these topics, trying to understand our contemporary environment, trying to construct what do we see as like, the 8 to 10 really important intellectual transitions over the last 200 years that made it possible to understand where we are and how we got there. And each of us has brought to the conversation a bunch of literature that we thought was really important. For me, it's largely technical literature or papers written by other machine learning researchers that I thought really impacted things. And for Matt, a lot of primary and secondary literature. The other thing that Matt brought me was a respect for the archive, meaning, like in research, sometimes there'll be like a cool result and you really want to show it to your friends, like you derive something or you ran an algorithm and you can't believe that it does, found something incredible in the data set, or rarely like there's a paper that you think is not as known as it should be and you want to show it to other people in your field. The respect for the archive, meaning like there's like so much ununderstood history of the way things got that way, and a lot of it is out there for the taking if you are willing to go figure out like, okay, where is the place where those documents are stored, or even like what is the weird website where I should be looking for this story, or what is the weird trail of citations, which are a lot easier to track down now online with a good electronic library than they were when I was an undergraduate. And that story, and so Matt has really shown me the respect for like getting your hands on or asking nice archivists at different librarians for a bunch of really interesting documents that I just wouldn't have made time to go track down otherwise. Declassified NSA oral history documents, or ends of the rabbit hole in terms of a citation trail or crazy interlibrary loans that I've made over the last few years for ancient primary text documents by people who were like code breakers in World War II, and plenty of stuff that didn't directly made it into the book, although it certainly informed my perspective on things.
So let's go through some of the key sections in the book, and the way my head is organized, I'm going to do it using, I guess, disciplines, right? So kind of very traditional, I guess my way of thinking is very traditional, right? So first off, statistics, right? So it strikes me, Chris, so statistics might have been very challenging, right? Because there's a lot of historical events and figures. Probably a lot of them got left on the cutting room floor. So sure. How did you narrow down to the key episodes and statistics?
So and for each
key figures, yeah.
You're right that you can't tell the whole story of statistics in like 2 or 3 chapters. So you're right, you have to choose a few transitions. The way we did it was not to say like what are the things that made statistics, but what are the things that made our present reality. So the driving contemporary reality is a world in which algorithms are increasingly shaping our political and personal and professional realities. For a lot of people, a large fraction of their reality is delivered in the palm of their hand, optimized for them via an algorithm. How did we get there? So you don't necessarily need to tell the story of everyone who was ever a statistician in order to tell that story. There's a couple of pivotal points that we chose. So within statistics, first we wanted, I am a big fan of philology, like the analysis of words. So I really wanted to leverage the contested nature of the word statistics itself. So it's a great story because we get so many fights about ideas and fights about words, and also fights about whether or not data should have a role in some conversation. There's so many times in the last 200 years where there's like a thing that a community understands, and then suddenly you get a bunch of data about that thing, and then you get these really instructive fights between the people who possess data about the thing and people who already have knowledge of the thing. In biology, there was lots of that when I was a graduate student, right? Like in the 90s, suddenly genomics happened and people could ask totally different questions about organisms that had been well understood for a century before that. So we take the word statistics, which enters in English language in 1770 and is about statecraft. It has nothing to do with data or numbers whatsoever. And it's a fun story to tell how over the next 50 years there were these fights between people for whom high statistics was the statistics of understanding the greatness of leaders of the state, and vulgar statistics was statistics done by people who actually made tables of different countries and how many animals they had and square miles and things like that. So one part of statistics is just to take that entry point into the language and how that's a fight. Then we take the point where statistics gets taken up for social causes and people start thinking, how can we use these mathematical tools to do an analysis of moral subjects? And we take the story of the Belgian astronomer Quetelet, who explicitly is like, we're going to be looking at moral facts now. We're not just going to look at how many people there are. We're going to look at how many crimes they have, how many suicides they have, and we're going to take these topics that he called moral topics and try to do an analysis of these things. How can we? And his view, because he was coming from astrophysics, was how can we take these tools like calculus that are so successful for predicting the location of planets and use them for the really important stuff like society? Again, we chose that because we see a lot of that in our contemporary environment. I myself, a lot of my research career the last 25 years has been taking tools from machine learning that are ridiculously useful and asking, how can we use these to answer questions from biology or health or something like that? So I empathize with Quetelet about feeling like, golly, these quantitative tools are so good. Can we use them for this entirely other subject matter? Thereafter, we look at the use of statistics for policy, and we look at the way that statistics gets taken into the academy. So statistics at some point goes from being about the state, which is right there in the word statistics, to being about mathematics and data, sorry, about data, I should say. And then it becomes a branch of mathematics. It sort of gets baptized by the academy and says, okay, this is a real academic field. En route, you get
so where is Chris, where is probability during all of this?
Probability was actually pretty well developed, around gambling. So probability as a mathematical field was already there. Try to make sense of data, though. We choose a couple of pivotal moments, like at Guinness, there was a mathematician named Gossett who published anonymously under the name Student. Student then was in conversation with Charles Darwin's less famous cousin, Galton. And Galton is the person who gives us the word regression and the word correlation and the word eugenics, which also makes clear like what his social program was in the Victorian era. Student also talks to Pearson, who we associate with correlation. And we tell the story about how for Pearson, causation was just a limit of correlation. He felt like correlation was the real thing and causation wasn't worth thinking about except as the limit of infinite or very strong correlation. And then on to Fisher, the scientist, who thinks about how looking at data can reveal what is scientifically true. And immediately thereafter to Jerzy Neyman and to Carl Pearson, Egon Pearson, son of Carl Pearson, for whom statistics is about helping you make decisions. And at that point, World War II happens. So we've sort of told the story about how statistics gets made real. And so statistics goes from statecraft to data to mathematics and then about truth. And then there's this breakpoint in the book where suddenly computers happen.
And there's some dark turns too around eugenics.
But there's plenty of dark turns, which is another thing for us not, I would say, not to shy away from. And plenty of years I've taught this class, and students, including stats majors, were like, I had no idea about any of this stuff. I actually think that we should tell our students more about the human beings who gave rise to our fields. And like, it's not a linear, perfect story, like, and then they attained enlightenment, and then they attained enlightenment, and then they attained enlightenment. Like these people had human interest. Quetelet was trying to create a field. He was trying to argue that he should have his own, observatory. Galton had a bunch of complications in the way he was trying to embetter society. Galton is also a really interesting story because he's pretty real clear about what he was after, and it's not like he was hiding what his interests were. He was clearly like, me and my cousins are great people. We should have more children than other people. And you can read his writing and see how he's writing about how he's going to do this, and it's going to be great for society. which I think is an important thing for every scientist to think about when they're building really powerful data-empowered algorithms. Like, how do we maintain critical self-awareness and make sure that we really think about the ethics of what we're doing? And as I sometimes say, like, are we the baddies? Like, we really need to think through as we develop and deploy machine learning products. How are we balancing between the rights of the people who are going to be using these algorithms, the harms that we may be doing to them, the role of justice? Are we doing things in a way that's fair, that's, you know, accentuating oppression, or that's addressing and redressing oppression? I just think that that sort of self-critical inquiry is part of what you learn by learning science as a story about scientists, you know, who are human beings. They're not perfect.
Okay, so then the next milestone, at least for me, so I'm actually structuring this, Chris, around how I my personal journey through all of these things, right? So first stats, and then at the risk of dating myself, I came of age actually during the age of data mining.
Yep.
So, which in retrospect, some of the things we were using under the umbrella of data mining, we now call machine learning. But anyway, so
data mining's in there, by the way.
Yeah, it is. Yeah. So, okay. By the way, so I associate Leo Breiman.
Yeah.
In that kind of
Leo is a great story.
So tell us about data mining and Leo Breiman. Yeah.
And so when we first started taking this, constructing the class, Leo was really at the forefront of my mind because he's such an amazing story, both as an individual and also as a representative of the relationships among different fields.
Right.
So Breiman had made his name as a mathematical probabilist, got tenure as a young person at UCLA, and then left a tenured position at UCLA, which for me, like as an academic, like, why would you walk away from a tenured position? Left the academy in order to go do, I don't know, impact the world, right? And did consulting work, and he was doing a bunch of computational statistics, like out in the wild, but maintaining some relationships with academia, which you can see because later in his life, people at Berkeley sort of invited him to come back to the academy. And so when he came back to the academy later in his life, he became a computational statistics professor at Berkeley. And he spent a lot of his last years trying to argue that the traditional statistical worldview, which, you know, had started with like Jerzy Neyman and others, even before World War II, and really become canonized. He felt like that was missing the boat on different ways of making sense of the world through data. And he writes a great paper in 2000 or 2001 called Statistical Modeling the Two Cultures, trying to lay out this argument. He gives a bunch of anointed lectures to fellow statisticians saying, you're missing the boat. You really need to start going to the NERPS conference and seeing what people are doing under the name of machine learning, which, by the way, is another drifting target. Even the phrase machine learning.
By the way, Chris, tell the audience, what was the reception to Breiman's lectures at the time that he was giving the lectures?
I have a hard time getting straight answers out of different people to that question because I have asked that question. But in general, I don't, it didn't take, right? So
he was an alien, right?
Yeah, that's one word I've heard people use for Leo near the end of his life. One touchstone for how the statistics community reacted is this 2004 NSF report about the nature of statistics. And if you look at that statistical report, it's got a bunch of responses from different commentators, including David Madigan, who used to be at Columbia, and including Leo Breiman himself. And I'm pretty sure we included a quote from Breiman in the book from that report. So 2004, NSF gets together a bunch of NSF-funded statisticians, and they read a report about what is the nature of statistics and what should statistics be for the next century. Breiman is caustic in his response to that report. He says, I'm going to try to do it from memory. He says, at a time when statistics is just starting to recover from the over-mathematization after World War II, would John Tukey even recognize this report? I think he would find it to be a great step into the past and not into the future. So I would say Breiman would say that it didn't work, like the orthodox mathematics community, certainly as represented by who the NSF was funding, didn't exactly, to Breiman's taste, take his gospel to heart and pivot at the time. One of the things we try to trace out in the chapter on data science, though, is the amazing changing nature of the way statistics as a community has viewed itself in the last 2 decades, including to the point where several very august statistics departments simply just started renaming themselves as departments of statistics and data science. I'm sure you know Bill Cleveland's essay from 2001 proposing the field of data science. I don't think we included this in the book, but Cleveland's paper was presented at a conference, and according to him, it did not go over very well at the conference. So there is a tradition of what I call heretical statisticians, most of them affiliated with Bell Labs, one way or the other, arguing that there's a different way of making sense of data from the tradition of what became canonized as core mathematical statistics post World War II. And it's been kind of interesting to see over the last decade how those arguments have really been taken to heart in the face of a variety of forces. I don't know that I answered your original question about big data, though, except to say that there is, about data mining, except to say that there is a chapter about big data asking the question, how exactly did it come to pass that people devoted so many resources and so many computational resources in particular to gathering and storing abundant data? That story, I think, is one of the keys to understanding why artificial intelligence has been such a moving target the last half century. That it was, the phrase started being used, and like it was coined in 1955 by a mathematician, and for the first half of the life of artificial intelligence as a field, there wasn't an abundance of big data sets to analyze, right? Instead, artificial intelligence as a paradigm was really dominated by people trying to, as Herb Simon put it, just program it, trying to figure out what are the right schemas, what is the way that a bacteriologist really thinks about the world, and encode that in a set of decisions, and then see what behaviors come out of that program. Just a very different paradigm.
By the way, to our listeners out there, they should definitely Google Leo Breiman because he was very practical. He even set up a software company for doing decision trees.
He's a great story, and there's a good interview with him by I think it's Ocean from Stanford. The great interview with Breiman just about who he is. So when I first met Matt Jones, it was in the spring of 2013, and he was giving a lecture on the history of machine learning, and I was very interested in the history of machine learning. So I went to the lecture expecting it to be about John Tukey, Leo Breiman, other sort of heretical statisticians who, to my mind, birthed machine learning as a mindset, even though they were active long before people started using the term machine learning.
Right.
And instead, it was actually much more interesting, and it included things like the history of government mining of personal information and other stuff that was outside my my wheelhouse. This was spring of 2013, and at the time, I was like, government mining of personal information. That sort of ended. That was surely after the after 9/11 and things like that, and that was right before the Edward Snowden revelations happened. And I said to Matt, you've skated towards where the puck was going to go. Like he was at the time, I was like, you are the world expert in this thing that is suddenly central to the way we understand data in our personal lives.
All right. So the next section, I'm going to lump two things together: data science and big data. So data science, I was, part of the cohort, around Hammerbacher and DJ Patel.
Yep.
When this term was coming out, and historically, we thought of it as, describing someone who, a data scientist, is someone who could do multiple things, not just one thing, right? So do a little bit of data acquisition, do a little bit of data cleaning, exploratory data analysis, visualization, maybe build a model, and so on and so forth. I'm not sure if it's really stuck that way because different companies have different notions for a data scientist. You can go, Chris, right now to a company. Some of them might consider someone who's doing BI a data scientist, right? So, but in reality, a data science teams normally are expected to produce reports, models, experiments, right? So depending on what you do, maybe you can only do one of those things. Maybe you get lumped into that team. So what's your take on how that term first arose and how it's being used today.
Golly. So one of the things we try to do in the book is to try to illustrate how many of these terms are themselves moving targets, and to be analytic about the way a moving target moves. It's useful to look at the different communities that use a term and what their interests are. So statistics was a good example, right? It's introduced and it means statecraft. It has nothing to do with data, let alone mathematics. Machine learning. We take a look in the book about what machine learning meant in 1984 and what it meant in 2010. We take a pair of essays written by the same person portraying the field in 1985 and 2010, and in 2010 sort of bemoaning that the field has become, so dominated by statistical methods rather than important things about cognitive science. Data science, similarly, much younger term in terms of the way that it's exploded since 2010, but it itself is a moving target. Data science in particular, I think, has had a lot of motion in part from industry, right? So statistics had a bunch of early industrial engagements, like before it was a field of mathematics, like, student was using it at Guinness to make better beer, for example.
Right.
And machine learning certainly has a lot of industrial usage. Artificial intelligence has really caught fire in industry, which has then caused it to catch fire in academia. And data science has really been led by industry, starting again with Bill Cleveland at Bell Labs, right? Not in academia, in 2001, writing this essay saying, I'm going to propose a new subfield of statistics called data science. And if you read that paper, it's really addressed at universities. It's like a letter to universities saying, you are doing it wrong. By the way, that builds on a longer tradition of, say, for example, the article by his colleague John Chambers, which is called Greater and Lesser Statistics, a Choice for Statistical Research in 1993. And by academic standards, like that is like rolling up the sleeves and fighting words to say Greater and Lesser Statistics, a choice for research. He's really writing a pointed essay from the perspective of an industrial researcher at Bell Labs to the universities. In any event, let me not go on a rant because I want to stay close to your question. Data science itself is a dynamic term. So I think what we try to do is we try to go to the primary texts, which include like Jeff Hammerbacher's essay in 2008, I believe it was, about the rise of the data scientist. And he has a great paragraph there about all the different things that, as he puts it, the diversity of skills in the data science team at the Facebook represented. It's really fun to go back and look at that same paragraph 10 years later and see how the world has matured such that one of those tasks is being done by people who are now called data engineers. One of those tasks is now being done by people who are called data analysts or machine learning engineers or people doing data governance. And a lot of the tasks that were rolled together in the, as we used to say, a unicorn of data science have now matured to the point that there are like separate groups and separate job titles for doing all those different things. And then it's a drifting term in academia as well, clearly, since multiple statistics departments have rechristened themselves as statistics and data science departments.
Yeah, and it's actually, if you go through the different data science programs across the U.S., just the U.S., there's so much variation, right?
That's right. So things, there's, I guess the point we want to make is that this is not atypical of fields, and you and I have seen academia go through things like synthetic biology, systems biology, nanoscience, and now data science, and many, to my mind, like fun and interesting fields that are at the intersection of and the forefront of the way we make sense of the world, but live outside an existing hierarchically organized ontology of ideas, because who needs hierarchically organized ontologies of ideas? We're out here like figuring stuff out, and it's super fun, and it's fun to talk to people from different departments. Anyways, so
by the way,
that's partly what we want to capture is how do we see that this is just another one of those, that is not atypical for fields to have a drift.
By the way, to our listeners, Chris is also the author of another book that I love that I called my 2022 Book of the Year, co-written with Alfred Spector, Peter Norvig, and Janet Wing, called Data Science in Context. And the reason I bring it up is my next topic is big data. And big data happened for a lot of reasons. One, people were just kind of drowning in data. They built new systems like MPP databases and Hadoop. But in my mind, one of the more seminal essays in this field was co-written by one of your authors, Peter Norvig, The Unreasonable Effectiveness of Data.
Yeah.
And I actually had them on the podcast recently. I asked Peter, so how do you think your, just jokingly, how do you think your the title of your essay held up? He said, "Hey, I think it held up pretty good, Ben." So, what's your sense of big data itself? Was it driven by the technology, or so? So, because in my mind, from my perspective, it was the term big data in the beginning, at least, was referring to these systems, Hadoop.
Mm-hmm.
Nothing in particular, but other than I'm drowning in data, my existing systems don't work. So now I have a big data system.
Mm-hmm.
By the way, you're talking to someone whose handle on Twitter is at big data.
I'm aware.
So what's your take on the term big data and in its origin?
So, yeah, my experience, and I assume it's yours also, is that around 2009, 2010, suddenly that term was being used all over the place. And it was being used somewhat in academia, a lot in industry, a lot by investors, and a lot by people pointing out there is a wide spectrum of companies that could be putting data to work in smarter ways. In some ways, it's very much like the birth of business intelligence. So you can go back and look at the original position paper from IBM, like coining the term business intelligence and saying there's a field here. And that paper, which is not a very long paper, is basically a position paper saying like all these companies really could be putting information to work in a much smarter way. So fast forward half a century rather, and there was a very similar narrative then in 2009, 2010. In part, Hadoop and other open source solutions were there, and in part the cloud, right? So you marry two different things that were happening there. Really cheap commodity compute, right? The idea that you didn't need to go buy a bunch of machines. You could just get out a credit card and rent machines, primarily from Amazon at the time. That was revolutionary and created the idea that you could just spin up a company in a sort of permissionless way, in a low viscosity way with a ridiculously small amount of investment. And then the promise of open source MapReduce. So the promise that anybody, you didn't need to go like buy an expensive Oracle license to deal with large data sets. You could, in principle, if you knew Java, you could spin up your own Hadoop system, and then you could take a difficult job like, I don't know, word count on 100,000 documents.
Yeah. I mean, I can attest to this. I mean, the early data scientists that worked for Jeff Hammerbacher at Facebook, when you talk to them, they're really kind of bursting with excitement, because they're using Hadoop MapReduce, but the things they were doing were not that, simple reports, right? But the fact is, now they can actually create this report. Before they couldn't, right?
So it was a time of exuberance, and history will say how rational that exuberance was. But yes, there was a lot of exuberance about potentially more companies that thought of themselves as sort of like boring companies with not very large data sets, and they couldn't afford, a whole fancy infra team to do interesting statistical analysis. Maybe everybody could do this because you could get out your credit card and use Amazon in the cloud. You wouldn't have to go buy a bunch of machines, and you wouldn't have to have a whole staff that knew how to put together those machines and build a bunch of racks and find space for it, which, some of us work in places where there's not a lot of space. And maybe you wouldn't need an expensive Oracle or other relational database license in order to do large scale statistical analysis. Maybe there was an open source solution and like all you needed was developers who were really good at Java. So, history will tell how much of that actually turned out to be useful for the companies that tried to do it. But that was a lot of the narrative in 2009, 2010. And again, I would claim very comparable to the narrative, among other times, in 1958 when IBM was advancing business intelligence as a new requisite skill set for companies.
So I would say so. The things have played out according to how you would expect, in the sense that the tools have gotten simpler, and more people can actually do all of these things, to the point where, how when you can do things as a matter of routine, you stop talking about it.
Yes. And a lot of things have become commodified, and a couple of players have become the dominant players. So there was a time where it was like everybody's going to have their own open source Hadoop team, and then eventually like people realized, man, that is a hassle, and the problems are the same in all companies. And sure enough, eventually like Amazon had its own solutions and Google has its own solutions. And like at this point, it's like Google's problem to deal with the big data. And like nobody wants to have their own Hadoop on premises solution.
Yeah, and honestly, now the buzzword, which by the way I helped coin, is lakehouse, right? So
Yeah.
all right. So now we're in the age of machine learning, which is really AI to most people.
Well,
right. So,
okay. So it gets back to our discussion about moving
right,
targets. So like it is a field which nobody, when I started in academia, nobody was calling themselves AI, right?
Yeah.
And it has come to the point that AI, which in the 50s through 70s was absolutely not about data, has come to mean machine learning. Also, by the way, machine learning itself has been a drifting target. You can look at what machine learning meant when the Machine Learning Journal started in '84, and it was, only barely about statistics, if at all. Right. So machine learning has actually become the thing we used to call pattern recognition. And a lot of the field called pattern recognition borrowed a lot of its techniques from statistics.
Pattern recognition. That's another term. So another term.
I'm watching you like you just saw a ghost. Like, oh, I remember that. Yes.
Oh, yeah. I mean, Chris Bishop's book on pattern recognition was exactly something right. I used.
It's called PRML, pattern recognition and machine learning. So for Bishop at the time, those terms were interchangeable. So the meme that I use when I'm teaching students is that people have ripped off the AI mask and it's become machine learning. But if you really rip off the machine learning mask, it's borrowing a lot of techniques from pattern recognition. You can go look at the first edition of Duda and Hart from 1973, pattern recognition, supervised learning, unsupervised learning, a lot of generative modeling. It's all there, just under the name pattern recognition. And if you really rip off the mask of pattern recognition, you'll find a lot of people using statistical methods like walled decision theory.
One term that kind of was very fashionable, but kind of disappeared is knowledge discovery.
Yeah.
Remember when it was data mining and knowledge discovery? But knowledge discovery, no one uses this anymore, right?
So a point we make in the book, and I'm sure it's you can only say so much in a book, but a point we make in the book is that a lot of knowledge discovery and knowledge engineering was a term that was a large part of this pre-data revolution of artificial intelligence, right? Because part of the approach to artificial intelligence, certainly in the 70s, was find experts and build expert systems, right? And so it's not the grand AI, it's a narrow AI or a weak AI that's going to focus on one problem. The way you're going to do that is you're going to find experts who are expert in that system, and you're going to go learn what their knowledge is. And a knowledge engineer, which is really like an ethnographer who interviews these experts and writes down everything they know, then incorporates all of that knowledge into a program, something that can be coded.
Yeah.
So that certainly was a field. And yes, when you say the name KDD, right, like you're building on a history of people who had aspirations and methods, and those were loosely coupled, right? Because the aspiration was to have artificial intelligence, but the method, whether it was going to be like proofs or schema or computer vision or neural nets, sort of shifted and drifted, right? The aspiration stayed the same.
One way of describing the different types of machine learning that I borrowed from Ben Reck, who borrowed it from you, is this whole descriptive, predictive, prescriptive, right? So is that still a useful way for thinking about these things?
I say it all the time at the New York Times and at Columbia. I'm constantly asking people to think about, what question are you really asking of data? Are you just taking a bunch of data and you want a simpler description? Is it that you just want something that's going to make a prediction in the absence of treatment? Like, does this image have a cat face in it or not? That's a prediction, but you're not hoping to intervene. Or is it the case that what you really want is advice on what treatment to intervene with in order to get the outcome you want? And that prescriptive modeling really touches on all of causal modeling, right? And it's a really different field from making predictions about a static data set that you're not making any claims to how the distribution that you're trying to model will change if you were to go in and do some intervention. So part of that is the difference between descriptive, predictive, and prescriptive modeling. It's also a statement about how hard your business partners have to work. Because if your business partners come to you and say, here's a bunch of data, give me a simpler description, that's not a lot of work. It's more work if they say, here's a bunch of data, and here's what I really want you to predict from all the other data. And even more work if they say, here's the thing that I really want, here's all the covariates that I think might be useful. They probably won't use that language, but features or signals or whatever they call it. And here's the lever I'm willing to pull in order to get that result. Now you're in the realm of prescriptive modeling. And roughly it corresponds to the three main flavors of machine learning: unsupervised, supervised, and reinforcement learning, roughly. But it's more about a statement about the mindset of the people you're working with or yourself. Like, are you looking for a descriptive model, a model that's going to predict what's going to happen in the absence of treatment, or are you really trying to figure out what is the right treatment to get what you want?
So pre AlexNet, the ImageNet moment for
Mhm.
deep learning.
Mhm.
If you look at the NeurIPS conference, which was
Mhm.
called NIPS back then, there were different waves of fashion, right?
Sure,
So whatever it was, the support vector machine people,
that's right. That's
and
right.
then the Bayesian people for a while. But now deep learning has been so dominant for over a decade.
Yep.
Before these waves only happened for like maybe one school was dominant for 5-6 years. But now, so is this in your mind? Is this unprecedented? This length of dominance of one technique? Now that you've written a history book, I'll put you on the spot.
Well, I'm kind of wired to have a contrarian view to any yes/no question anybody posed to me. I'm kind of wired to answer no. So here's two no answers.
Okay.
One no answer is the thing that people are excited about in deep learning and large neural networks now is not the thing that they were excited about then, right? Then it was like tagging the images. Now it's generative AI.
Mhm.
Now the thing that's really capturing everybody's attention is how do we use large scale neural networks actually to generate new image data and new text. That's what's really capturing people's imagination now. That's one contrarian answer. The other contrarian answer is, well, it's worse than that because it's not really a decade, right? I mean, neural nets have been around arguably since McCullough and Pitts had the idea in 1943.
No, but their dominance,
Their dominance
their
definitely
monopoly,
started in
their monopoly,
in
yeah,
2012. Yeah, that dominance. Is there anything else that dominated for a decade?
It's amazing, Chris, the dominance in the following sense, right? So if you talk to old school computer vision people who, were using SIFT Hug back in the day,
Mhm.
I mean, nowadays, none of these students know any of that stuff. They just go straight to deep learning, right?
Absolutely.
Yeah,
Yeah,
that NLP is having the same kind of thing, right? So, yeah.
you may be right. It may be hard to find another example of a technique that's so dominated for more than a decade, other than like ordinary least squares. Ordinary least squares, it's doing pretty good.
So,
Still using it.
be, I'll talk to you more about AI, but there's one thing that I wanted to bring up, which is kind of something that I've been interested in a lot in light of China, which is Wiener cybernetics systems theory. Because if you look at kind of the Chinese, what do they call it, the social management system, a lot of it is inspired by kind of this whole cybernetics. What do they call it? Social cybernetics, the intersection of systems theory and cybernetics. So, to what extent have people forgotten about Norby Wiener?
Well, you hear cyber a lot more than you hear Norbert Wiener.
Yeah.
Yeah, cyber, of course, has become a whole name. And yeah, Norbert Wiener's work doesn't inform it so much. The conversation around China, I don't think I've really heard any connection, any people talking about
because there's
connection between it and Norbert Wiener's ideas.
Well, there's a student of Carmen who was here in the U.S. and then his security clearance got revoked. He got basically his career stalled here, and then he went back home to China, and then he started all sorts of things there. The rocket program, basically the use of systems theory for social management. Because their grand dream is this kind of autonomic system, right? Which is self-management, self-managing, self-healing system. This is the grand vision if we can just build a system like this. So a lot of it, if you read about it, it traces back to this one guy who was forced out of the US in some ways.
I regret that there's a lot of countries and a lot of histories that we don't include in our book, but maybe for the next book. but no, we
Yeah, I
don't.
just
We
happened
we
to
touched on
listen.
things happening in the UK. There's a couple of references to things happening in France. A couple of references to things happening in India. But I don't think there's much in the book about what's happening in
Yeah,
China.
I didn't know anything about this, but I happened to listen to a bunch of podcasts about China.
Hmm.
Uh, this person's name has come up. I'll send it. I'll send it to you. So anyway, so uh, back to AI. Um, so you spent a lot of time in the book talking about responsible AI and AI ethics, but not necessarily in the context of very prescriptive about what people should be doing,
Right.
but more along the lines of this is what people have forgotten to do in some ways, right? So some of these big companies have kind of maybe proclaimed that they're doing a lot of things around responsible AI, but maybe if you look closely, maybe not so much, right?
In this book, there's a chapter called "The Battle for Ethics." So, I mean, I've certainly been interested in ethics for a while, and in part because I'm like teaching engineers who are going to go into private companies, and also at the New York Times, we take very seriously how do we think about the ethics of developing and deploying machine learning models. Um, in the first couple of years we taught the class, it was a little disjoint, like thinking about ethics and the applied ethical tradition that informs the way that a lot of machine learning researchers think about ethics. And then it became very integrated because machine learning started to have a real problem with ethics and a lot of very visible discussions, fights, hirings, and firings around ethics. So by the time we finished the book, it was actually quite integrated to talk about the history of data and history of ethics to data, the history of data and the history of ethics together, because we could talk about the way that these companies had struggled to meet a public narrative around ethics, and it is difficult, right? It's not part of the intellectual traditions that like part of the book is to build this cord from different braids, right? And to see how statistics and logic and mathematics and big data and computer science and ML all sort of came together to form this soup, or this shared narrative. And ethics, sort of applied ethics, also has this separate tradition, right, which was really growing from a different community. So that's part of the lesson of that chapter, is to trace that battle. But you're right, we don't write it in a way that tries to take a view on like what should have happened, but rather just to try to give some context for understanding how did this battle come to be, how is it going to be resolved, what are the intellectual traditions that this battle is actually building on.
And would you say, Chris, that at this point we're much further along, right? So, I mean, now there's conferences, people are writing papers, people are building tools. I mean, it's not a perfect situation, but there's some level of consciousness. If you go into these companies, they have people focus on alignment. So there's some effort. I would say that maybe 10 years ago, none of these things existed inside these companies, right?
So things have matured,
Yeah.
but I don't know if I would say that things have wholly moved forward, because a lot of it has moved backwards. The intensity of companies trying to make a commitment to ethics in some ways was more clear a year ago or even 2 years ago, right? A lot of these companies have fired or weakened or undercut the groups that were hired to think about or constrain or guide or build tooling to support ethical AI, right?
But set aside some of these companies, the ML community broadly.
Oh, absolutely. And in fact, the very opening of our book is my friend Hannah Wallach talking at NeurIPS at what would become the first of a very profitable, meaning intellectually fruitful, set of workshops about what was then called FAT, Fairness, Accountability, and Transparency, or FAT-ML, which became FAT-STAR, which became FACT. So absolutely is much more intellectually mature than it was a decade ago. Plenty of, I mean, there's conferences, journals, right? All the things that you associated with the creation of an intellectual community have really matured. And there's an active dialogue in different departments, including technical departments, about how should we think about fairness, accountability, and transparency, ethics, mostly as a technical problem, Separately, there's a bunch of departments around science and technology studies that are thinking about socio-technological systems, including ethical impact of technologies. Those, I think, are doing a great job building on earlier traditions of applied ethics of technology and seeing how data and data-empowered algorithms borrow and, or rather, inherit a lot of what we've learned over the last half century from thinking about the ethics of technology in general.
I would say I agree with you in the sense that probably inside these companies there's a more awareness, but there's a lot of pressure to move quickly and move fast, right? So especially now with the rise of these generative models and language models becoming more powerful. Do you really want to get left behind when your competitors might be moving faster? So I think we're in for kind of a wild ride for the next year or two, unfortunately. I mean, there's going to be systems that might get released that may not have the level of scrutiny.
Almost surely there will be deployments that will violate our ethical norms.
Yeah. I mean, and the fact is, I think right now, most people assume that there's going to be only a handful of groups building these large models, but we're already seeing, medium-sized models that are reasonable, that people can take and build on top of. And the fact is, a lot of companies may not be comfortable working with just an API. Right, so they will want to bring some of these models in-house, which actually is scary for me on the ethics front, because it's one thing. So these companies, first of all, will have to staff up to have some level of knowledge in order to fine-tune and customize these models. So guess what? Do you think they'll staff up to build like an alignment team and an ethics team right off the bat? Maybe not, right? So.
And not usually. I mean, that's not the norm. And in fact, just this week, some major company just fired their ethical group. I'm forgetting exactly what the headline was. So, yes, when there's belt tightening, apparently, ethics teams are one of the first to let go. We've seen in the last half year.
All right. So you've written 2 books in presumably 1 year. Because the other book the other book you co-wrote came out in December. So this one is, when is this coming out? Is it May?
In 7 days. It'll be
7 days.
It'll be March 21st that it's released.
Yeah. So then how many more books do you have in you, Chris?
I don't see another book anytime soon. I need to go write some papers and do some other things.
Yeah. No, but I mean, I highly recommend this book. This is a book that you can actually give to managers, and I mean, this is meant for people. Everyone can read this book, right?
Any curious person?
Yeah. And by the way, as some of our listeners may know, there's a ton of books on the history of statistics. There's a biography of many of these people, Neyman, Fisher, and stuff. But this is really kind of packaged in a way that helps you make sense of how we think about these things today.
Yeah, the role of statistics, like up to World War II, we had lots of secondary text to draw on. You're right. There's biographies of Neyman and other people. The story of data post World War II, we found that there was not a lot of secondary text to draw on. We really were digging into the primary text and our own lived experiences.
So someone will need to write kind of a history of ML.
Absolutely.
At some point, right? So
absolutely. That is a book to be written.
Yeah, which will when would you start this book? I mean, so what
a book on the history of ML?
Yeah. What year would you start it?
Well, no later than 1959, but I would certainly want to start it. If I were writing it, I would start with Udney Ewell, 1895. So Udney Ewell does a multivariate regression in order to, as he put it in the title of the paper, understand the causes of pauperism in England. And he does a little multivariate regression where he fits like 4 parameters. And then he writes in footnote 25, this is actually not a causal model. I mean, he doesn't use those words. He says, strictly speaking, read associated with rather than causes. So it's a great example of somebody taking an important thing in the world that they really cared about and saying, I'm going to use a predictive model to try to understand it. And then what he really wants to do is interpret that predictive model as a policy statement. In his case, he had some observation like the correlation, the coefficient that relates how much assistance you give people with how many poor people there are in different regions of England is positive, and therefore he concludes that helping people causes poverty. And then again in footnote 25, he says maybe this is not actually a causal model, but it's right there in the title of the paper. So I think that's a good ML story for saying like, function approximation is like at most half the story, right? You can build a really good function approximator. You could build something that absolutely predicts how many poor people there are in different regions of England. Doesn't mean that you're going to have something that's useful as a causal policy.
Yeah, I'm actually surprised this book doesn't exist. Someone will have to write this book. Yeah.
I'm a little tired, but yes, there are certainly a bunch of historians that are looking at data and its history. There's a good book by the late Niels Nilsson about the quest for artificial intelligence. So I think it's still on his.
When does it end? I mean, what's the last year? Does it reach deep learning? I hope.
No, but it reaches neural networks.
Okay.
So I don't know the history of deep learning, and well, that's for other historians to work out. Ben Recht has this book available at mlstory.org that sort of briefly tells the story of machine. Ben Recht and Moritz Hart. So if you go to mlstory.org, just to plug Ben's book, that's a nice book about the story of machine learning.
Oh, interesting.
It's slightly more aimed at technologists, rather, and it's got proper mathematical parts in addition to being the story of ML. But
both cool guys. So, and with that, thank you, Chris.
My pleasure. Thank you for having me.